Hello everyone. So this is a question from JEE Advanced 2026 paper 2. In the following reaction sequence, P, Q, S and T are the major products, okay? And the correct statements about P, Q, S and T, okay? So few statements are given. The chapters involved is amines, alcohols, phenols and ethers, okay? So to find P and Q, we are starting with aniline, okay, and which is first subjected to, you can see, CH3CO whole twice O, which is known as acetic anhydride. So this guy is acetic anhydride, and pyridine, which is a base. Okay, so that is, so we are starting with aniline, and first we are subjecting it to CH3CO whole twice O and pyridine. Okay, so basically we are doing acetylation of aniline. So this reaction is known as acetylation of aniline, or you can also say that we are introducing the acetyl group, okay, which is the COCH3 group in aniline, okay, using this reaction. And this reaction is also called protection of NH2 group by acetylation using acetic anhydride. Okay, so what actually happens is you have NH, and I'm separating one H, and also you have, you know, acetic anhydride, that is this guy, CH3 C double bond O, O, C double bond O, CH3. So what happens is uh, this bond breaks and this part of the molecule gets attached here, and this H goes and becomes a part of this CH3COO. Okay, so ultimately we will get benzene ring, NH, C double bond O, CH3. Okay, and since this H has become a part of this, so we will get CH3COOH as the side product. Okay, and so this guy is known as our aceta-anilide. Cool. Then we are subjecting this aceta-anilide to, so the second set of conditions are concentrated HNO3, concentrated H2SO4, and also the temperature is around 288 Kelvin. Okay, so basically we are doing its nitration, okay, using this reaction. So we are doing the nitration of aceta-anilide. Okay, so therefore we will get benzene ring, NH, COCH3 and NO2. So this is known as para nitro aceta-anilide. Okay, and this is the major product. We also get, side products, that is NHCOCH3, and in the ortho position we have NO2. So this is known as ortho nitroaceta-anilide. So this is the minor product. Okay, cool. So since in the question they have mentioned that P, Q, S and T are the major products, so therefore this guy is my P. Okay, and then we are subjecting it to acidic hydrolysis. That is, I have P, which is para nitroaceta-anilide. So I'm subjecting it to hydrolysis. So upon hydrolysis, we will get back the amine group here. Okay, so we will get NH2, NO2, and also CH3COOH is the side product. Okay, so this is known as P nitroaniline. Cool. And then we are subjecting this P nitroaniline to second set of conditions, that is NaNO2, HCl, and also the temperature is 273 to 278 Kelvin. So from the temperature you can figure out that we are trying to do diazotization. Okay, so basically we are having p nitroaniline, that is this guy, and we are subjecting it to NaNO2 HCl around 273 to 278 Kelvin. In this, you can see this guy is a 1-degree aromatic amine. As you can see, NH2 is attached to one carbon, and this carbon is a part of an aromatic ring. So it is a 1-degree aromatic amine, which will be converted to its diazonium salt, and the process is called diazotization. Okay, so therefore, we will get N2 plus Cl minus NO2, and obviously there will be certain side products like NaCl plus H2O. Okay, so the reaction wants the major product, so therefore this is the major product, and hence this will be our Q. Okay, cool. And to find S and T, we are starting with this guy, benzene ring CH, CH3, CH3. Okay, and this is actually cumene, which is also known as isopropyl benzene, okay, which in presence of O2 undergoes aerial oxidation, that is this guy, in the presence of O2 undergoes oxidation to give us benzene ring C, CH3, CH3O, OH, okay, and this is known as cumene hydroperoxide. Okay, which in presence of H plus, that is this guy, in presence of H plus will yield phenol ultimately. Okay, so therefore cumene hydroperoxide in the presence of H plus will give me phenol, so I'll be getting phenol. And also there is a side product CH3 C double bond O CH3, which is acetone. This is our important or the major product, phenol. And then we subject phenol to second set of conditions, that is NaOH and CO2. Okay, so we subject phenol to NaOH and CO2, and this is nothing but Kolbe's reaction. Okay, and phenol upon Kolbe's reaction, we will get OH and C double bond O Na. Okay, and this guy is known as sodium salicylate. Okay, and this will give, and this guy, that is sodium salicylate, upon acidification, that is acidic hydrolysis, will give salicylic acid. Okay, so when sodium salicylate, that is this guy, is subjected to acidic hydrolysis H3O plus, we will be getting OH COOH. Okay, and this is known as salicylic acid. Okay, and this is our S. Okay, and when S reacts with Q in presence of aqueous NaOH, coupling reaction happens. When S reacts with Q, so we know what is S. We have also found out Q, which was, if you remember, benzene ring, diazonium salt, and NO2 group in the para position. In presence of aqueous NaOH, coupling reaction happens to form brightly colored azo compounds. Okay, to form brightly colored azo compounds. So we'll see, I'm putting a star mark here, it's important. Okay, so this coupling reaction that I'm talking about is an example of electrophilic substitution reaction in which diazonium cation, that is Q, will be acting as an electrophile, and the aromatic compounds, in our case it is salicylic acid, if you remember S, will be acting as the nucleophile. Okay, so the reaction will happen in this way. So I have Q. This is our Q. It will react with S. So I am writing in this fashion. I'm separating one H from the para position, and I have OH and COOH in the ortho position. So these two will react in the presence of a base OH minus, and the temperature will be around 273 to 278 Kelvin, and these two will be reacting and giving me T. Okay, so in this reaction, this H and this Cl goes out, and there is a new bond between this nitrogen and this benzene ring. So we will ultimately get T, which will look something like this. Plus HCl will be the side product. Okay, so this is my T, and this is the bright colored azo compound that I was talking about. Okay, so now since we know P, Q, S, and T, so let's look into the options one by one. Okay, option A says that Q on treatment with ethanol, Q when it is treated with ethanol, will generate an aromatic aldehyde. Okay, so Q is this guy, N2 plus Cl minus and NO2 in the para position. So when it reacts with ethanol, that is CH3 CH2OH, will be getting nitrobenzene as one of the product, nitrogen gas, HCl, and also will be getting CH3 CHO. Okay, so this guy is, ethanol, which is a aliphatic aldehyde. Okay, the option says that Q on treatment with ethanol will generate a aromatic aldehyde, so which is incorrect. Okay, so therefore statement A is incorrect because we get a aliphatic aldehyde. Okay, cool. Statement B says that S will give S gives positive phthalene dye test. Okay, so we need to know what is phthalene dye test. Phthalene dye test is an organic test to detect the presence of a phenolic OH group. Okay, this is used to detect presence of a phenolic OH group. Okay, so in this test, the organic compound containing a phenolic OH, okay, so that organic compound reacts with phthalic anhydride. So phthalic anhydride looks something like this. Okay, in presence of some amount of acid to form a colorful phthalene dye. Okay, so it gives us a colorful phthalene dye, which confirms the presence of a phenolic OH group. Okay, so S is, we have already derived, S is salicylic acid, that is OH and COOH. It contains a phenolic OH group, as you can see. Okay, so therefore it gives positive phthalene dye test, so therefore B is a correct statement. Okay, cool. Then C says that P is a dinitro compound. Okay, so we have derived the structure of P, which looks something like this: NHCOCH3 NO2. So you can clearly see it contains only one NO2 group. So therefore C is a incorrect statement. Okay, and option D says that T is a colored compound. Okay, so we have already derived T, which is NO2 connected to benzene ring, N double bond N, which is connected to a benzene ring containing OH, and COOH in the ortho position, right? So this T is obtained after coupling reaction, if you remember, between diazonium salts and electron-rich aromatic compounds. In our case, it was salicylic acid. So therefore, products which are formed after coupling reactions are, brightly colored azo compounds. So this is an example of a azo compound. And color of azo compounds, I mean, they are brightly colored, and that color of azo compounds is due to extended conjugation involving double bonds of both rings through N double bond N double bond. Okay, so I will write that down. Color of azo compounds is due to extended conjugation involving double bonds of both rings through N double bond N. Okay, so if you can see, there is, conjugation here in the ring, double, single, double. So there is double, single, then, N, there is a double bond, then N, there is a single bond, then there is double bond, right? So can you see there is extended conjugation, double, single, double, single, double. So because of this particular conjugation, azo compounds are, brightly colored. Okay, so therefore D, which says that T is a colored compound, is a correct statement. Okay, so therefore, the final answer is B is a correct statement and D is a correct statement. Okay, so B and D are the correct answer. Okay, thank you.